Sir, when we say data center or when we want to build a data center, we always think of water is being used. And people are scaring others saying that water will be the new war. Is your data center using a lot of water?
We don't use any water at all for cooling.
What is that you are saying? You are an air-cooled data center?
Yes, completely.
Okay. Is this technology available for transfer for others?
Yes, very much available.
Okay, now we're talking more about the power optimization, CPU, GPU utilization. Welcome to the third series. I am Vijayanand Gurudev. With me is co-founder and CEO of Vigan Labs, Mr. Srinivas Varadarajan. Welcome, sir.
Thank you.
This session will be beating around compact data center cooling versus traditional data center cooling. I know the earlier two series also address the same thing, but here we want to understand how Srinivas has built a micro data center, and he has condensed the size of the data center into a very small volume, and how he is able to optimize or achieve operational excellence. Compact data center cooling as a myth is only suitable for edge deployments, not for enterprise AI loads. What is your take on this, sir?
I don't think so, right? See, today what's happened in data centers today, the meaning of small is changing, right? Today, as I said, as we looked at last decade, right, we moved from, 100 nanometer to 40, 28, 15, 10, 7, 5
4.
to 1 and 0.7 now coming in. So we're able to pack a large amount of compute and storage in a small area. So it's again, the size doesn't really matter. Look at the workload, right? Today, example, just take the latest, SSDs available, NVMe drives available. You can pack 5 to 6 petabytes in a rack, right? Like that, and you can pack probably look at a CPU core set, can pack probably, 10 to 20,000 cores in a rack. So amount of compute and storage you can pack in a rack is fairly enormous, okay? So I think, a 10 rack, let's say, of GPU set, let's say, it can do enormous amount of work, right?
Correct. So as we also spoke in the earlier series of the more and more density of transistors happen in a small given area, the heat isolation also happens, the heat islands create more.
Yes.
So as we compact and have more compute and storage happening in a rack, how will the cooling challenges be addressed going forward?
I think as we speak, right, so there are new technologies coming in. The air cooled has reached, I said, the limit is 30 to 30 kVA. Then you do a heat exchanger, you can do 30 to 40 kVA.
Okay.
Beyond that, you need to do liquid cooling.
Liquid cooling is
liquid cooling, and slowly immersion cooling is emerged because all the equipment are compatible. So I think new technologies are coming. There's solid state cooling emerging. So I think there's a lot of research going on at the material level itself, how to take the heat out.
Okay.
From
just
chips.
a wild thought, we have a lot of nitrogen available. Can we use nitrogen cooling?
See, this is already cryogenic cooling. See, if you look at the quantum, we use cryogenic cooling, right? Liquid nitrogen.
Liquid nitrogen.
But liquid nitrogen, cryogenic cooling is very expensive, right?
It's not affordable and not.
So it's not required for, okay. So when
you,
why do you want to do it minus 275 degrees? when you need to keep the power level up at 30 degrees, 30, 40 degrees, right?
So we are still not there to use cryogenic.
I think when the quantum comes in, you need cryogenic.
You need cryogenic cooling. Okay. Sir, if you want to build a new data center, will you be adopting liquid cooling?
Again, I'd say I would answer the question differently.
Okay.
Depends on what kind of workload you have, what kind of business you're running, right? So doing it purely inference, right? Just inference or traditional workload. Say it's a cloud, compute as a service, compute and storage, which can happen, 10 to 20 kVA.
Okay.
Run inference, we have seen that we have been able to optimize inference, to less than 30 kVA. As long as you keep the workload within that envelope, then your cooling strategy is simple. So that's why I always ask question, what do you want to do? What kind of workload do you want to do?
What kind of workload you want to do?
Want to do training? Training requires a lot more compute capacity. You may want to do liquid cooling, right?
So it's like if you want to have a helipad, don't build an airport.
Yeah.
So you just build a helipad.
Okay. Yes, that's right, yes.
So moving on to the next question, like higher rack density always means higher operating cost. I think you have busted this myth. Can you give more insights on this?
See, basically, rack density, what does it mean, right? You are packing more compute or storage into the rack. As long as you can control the power, manage the power and cooling envelope, so you can improve the efficiency, right? So what we have done today is, higher rack densities with a better PUE. So improve the overall efficiency, right? Efficiency from your transformer to the bus bar to your rack, chip level, board level, everywhere you make it more efficient, energy efficient. Then you actually you achieve the overall efficiency. So
our IPM Plus is working across the spectrum.
Yeah, we have built, basically we use AI across the board, right? From your electrical panel, it is anomaly reduction and energy wastage, to your server level where we do the energy optimization at the chip level,
Mhm.
to your chiller, right, closed loop control system. So basically, we have put AI across the spectrum, right, to optimize energy consumption and reduce the energy wastage across the board.
So way back in 2019 or 2020, when IPM Plus was
Yeah.
developed, you had actually built an AI agent.
Yes.
So can you give us more insights on the agent which you already built and it has been in use for the past 6 years?
Yeah. See, basically, what happens, what we call agentic AI, right? What does agentic AI do? It works autonomously. It understands things. You don't need to. It's already understands. It learns itself, right? Today, let's look at today. The workload pattern of server is different, right? Changes. There are so many CPU chipsets. Operating systems are different. You can't go and keep on training,
Correct.
programming them, right?
Correct.
So what we built, before the LLMs came in, we built our own neural network, right? Because there's a lot of parameters are there to decide, right? To predict the load on the server. So right, there's so many parameters, just not the CPU, memory, network, I/O. Dozens of parameters are there. So you need a complex neural network, right, to understand the behavior of the systems, identify the load pattern.
Okay.
Based on the load pattern, you control the chipsets, right? As I said, there's a dynamic frequency scaling. You do that by predicting, right? Predicting the workload and taking action, right? So we built that long way because otherwise it's impossible to control. How do you manage, right?
Correct.
You can't use a traditional statistical algorithm, right? You can't use the average as a predict.
Correct.
It will be inefficient. So we use AI long back. ML built our own, neural network and ML models to basically control predict the CPU usage, load, and then control the CPU frequency or the cores, right? Turn off the cores.
So we can definitely go around in the market and say that Vigan Labs has got the technology to run a small micro data center with minimal carbon footprint and also require only kilowatts of power and not megawatts.
Yeah, sure. You can do micro, even you can do large. The same principle apply to large, right?
Large
So you make
also.
it efficient, you scale it up, right?
Okay.
You made one rack efficient, you do 1,000 racks, the same principle applies, right?
Applies.
It's efficient, right?
Okay. So we have now built a few data centers, micro data centers for premier institutes across the country.
Yeah.
So are they using all the existing innovations what you have done? Has it been applied there all as well?
I think, yeah, we try to apply, right? So our aim is basically how do you create sustainable energy efficient action. So we are applying we are replicating what we did in Mysore. May not be 100% as much as possible, right? Some place where we have opportunity to build a building from scratch, we ask people to use our design.
Okay.
Where you already have existing building, we try to see what can be retrofitted.
Okay.
Achieve the maximum possible efficiency within the given constraints.
Given constraints of time, money, and
yes.
Effort. The next question would be again on density, which you already answered. So moving on, again asking the same question: are the new hardware more energy efficient, or are they consuming more?
I think hardware is becoming efficient again. If you look at Moore's law, right? Moore's law, we have gone beyond the Moore's law now. We are doing 2D and 3D kind of silicon. Hardware is becoming continuously efficient. What's purpose means the software, right? Software, because you are taking advantage by the hardware efficiency. Nobody is focused on improving the efficiency of software. Right? So what DeepSeek did was try to make the model more efficient and the same hardware you can. So I think there's still a lot of scope of improving algorithms, making them more efficient, and the new hardware, right?
Okay. So compact cooling will always help. Addressing isolated or heat islands always help.
Yeah.
And thereby your PUE can be improved upon.
Yeah.
Is what you say. Okay. So now off late we are listening to this thing called AI data center.
Yeah.
So that's a new
Yeah.
what is the new jargon in the industry? Should they prioritize on compute performance or energy, or both?
I think you need to both, right? See, energy is a challenge today. Today, energy is limited, right? See, it's just like you can produce a computer, I can ship, right? I can't manufacture energy overnight, right? So there's energy, generating energy takes a lot of effort because it's not in your hand, it's not under control. So if you want to control, you need to build your own power plant.
Correct.
Or you work with your distribution company, they need to build, energy generator, right? From the generation to the distribution, there's a lot of, many factors involved and many stakeholders involved. So you always need to focus on optimizing energy because, energy cannot produce overnight, right?
Correct.
It takes a lot more time.
So as we adopt AI in a much bigger way, and as a nation is also investing a lot into AI infrastructure, we are in future we are going to see a lot of AI data centers as well, specifically coming up across the country. So is Vigan Labs ready to partner with anybody who wants to build such data centers? with the available technology and with continuous research what Vigyan Labs is doing, and then build better world, better place with AI data centers. And also, as a nation, we have acute shortage of potable water, acute shortage of power generation, and land. So, and all these three are already addressed by Vigyan Labs.
Yeah.
What would you say here?
I think we are glad to work with partner with others, right? See, we created technology not just for our own consumption, right?
Correct.
So make it available as a. I think what we are trying to say is we are trying to democratize data center, right? Everybody and anybody should have, every enterprise, small or big, large.
So this is
They
in
want to build their own data
respect
centers.
with the
We'll
DPI.
be able to partner with them, provide our technology for people to build and manage their own data centers in a very efficient way.
Okay, now giving back one question to the audience. A cooler CPU is always more efficient than CPU. Please have a look at it and then you try to answer this. With this, we'd like to end this third session. Thank you.